Emmert International proudly presents the 2008 Hauling Job of the Year entry for the Specialized Carriers and Rigging Association. Emmert International was contracted by a worldwide leader in power equipment manufacturing to transport an extremely overweight and oversized generator from Houston, Texas to Pueblo, Colorado. Immediately upon execution of the contract, Emmert began orchestrating the detailed planning and engineering process that ultimately took 2 years to complete. It's a formidable challenge to transport a generator that is over 40 feet long, 15 feet 4 inches wide, and 17 feet high, weighing 826,700 pounds, some 994 miles. On June 19, 2007, Emmert International safely and successfully completed the transportation of the generator from Houston to the Comanche 3 power station located in Pueblo, Colorado. Emmert International approached the project using a best methods transportation tactic that thoroughly investigated all possibilities of transport. After months of engineering analysis and route surveys, it became clear that use of Emmert International's BBCX1000 20-axle Schnabel Rail Car was the absolute best method of transporting the generator. There were a couple of engineering hurdles that Emmert International would have to overcome to use the BBCX1000. The generator, when loaded onto Emmert's standard load bed, did not exceed the 1 million pound capacity limit of the BBCX1000, but the gross weight did exceed the limits of some of the bridges along the route. Faced with this test, Emmert, working closely with the BNSF and customer to engineer and fabricate a new loading bed which was custom fit to the customer's needs. This unique design incorporated the use of a temporary compression shaft and the load bed to ensure that the generator body itself would not be subject to any compressive forces. The new loading bed is significantly lighter than the standard loading bed. Emmert designed a unique new combination that utilizes the combination of compressive loads and conventional load platforms. The final design would utilize the generator to help support its own weight while being transported, in effect becoming part of the rail car. Emmert selected a local fabricator in Oregon to fabricate the new loading bed as part of Emmert's desire to keep control over the critical time-sensitive project and help support the local economy. The new loading bed was fabricated using a high-tensile alloy steel, which is both lighter and stronger than normal steel, which reduced the gross weight to within the allowable limits set by the railroad. These two design elements allowed the new 47-foot loading bed to be significantly lighter and considerably smaller than what is traditionally used for loads of this size. Because of schedule constraints, the new loading bed could not be fit tested to the BBCX1000 before its maiden voyage. After fabrication was completed, the load bed was immediately transported to Houston. Once the loading bed arrived in Houston, crews began attaching the new loading bed to the BBCX1000 for the first time. It was critical that every pre-designed hole, nut and bolt, and pin be accurate. The BBCX1000 was reconfigured from its unladen transport configuration to receive the generator by moving the two Schnabel arm sections 60 feet apart from each other on the 200 feet of straight and level track. The load bed was placed between the Schnabel arms and cribbed to the proper height, away from the port's loading dock. Because the BBCX1000 works by compressing the load that it carries, Emmert International had to install a 47-foot-long compression pin to transport the entire BBCX1000 in its loaded configuration. Safety tests were performed, and then it moved to the assembly area to the loading area. At the loading area, steel barge ramps and plates were then placed underneath the loading bed to satisfy the load-bearing requirements of the wharf. The critical moment was at hand. The BBCX1000 with the new load bed was in position to receive the generator from the ship's hook without a fit test. Would it fit? Months earlier, Emmert worked with the ship's owner to ensure that the generator was orientated on the ship in Japan so that when it was discharged, it would be facing the proper direction so the BBCX1000 attachments and design features would align properly as each end required different connections. The ship's crew removed the 826,700-pound generator from the cargo hold of the ship. The exact dead center placement of the BBC X1000 Schnabel Rail Car was performed flawlessly, and the loading bed fit to exact tolerances. Impact recorders and dial indicators were installed at each end of the generator to ensure there was no added stress or pressure to the generator during the transport and readings recorded at each stop. After loading, the BBC X1000 was inspected and safety tests were conducted to ensure all designs and specifications were met. Employing the use of the custom-engineered and fabricated load bed, the BBC X1000 ended up with a gross weight of 1,975,700 pounds and measured over 398 feet long, 15 feet 4 inches wide, and 19 feet 9 inches high. The all-clear was given by the rail inspector, BNSF, and Emmert to begin transport. Months earlier, Emmert International worked directly with the BNSF at their Fort Worth headquarters to secure approval for the supersized transport. The BNSF's Engineering and Operations Department assembled a special team to develop a special train movement plan, coordinating movement of the spacer cars required for load distribution, and establish key contact persons in the event of problems, which included detailed documentation and drawings outlining step-by-step procedures for the BBC X1000 movement and rail load shifting plans. The railroad initially gave Emmert 22 impassable locations along the railway that would deny the generator passage, as well as 2 places where Emmert would have to offload the generator from the BBC X1000 and transport it by road past the obstructions, then reload it onto the BBC X1000. After further review and inspections by BNSF and Emmert, it was determined that all of the obstructions could be overcome by using the side shifting, lowering, or lifting capabilities of the BBC X1000 that allowed the generator to remain on the rail line throughout the entire journey. With the inspections complete, the BNSF granted Emmert International permission to transport the generator. In downtown Amarillo, Texas, Emmert had to negotiate the generator under a bridge that required full use of the BBC X1000's hydraulic system to safely lower and shift the generator to within a fraction of an inch of the tracks to maneuver under the fixed overhead obstruction in order to maintain sufficient overhead clearance, while at the same time maneuvering around the supporting bridge abutments on both sides. While entering under the bridge, the BBC X1000 was required to shift to the left, giving about 1/2 inch clearance between the generator and the bridge. After clearing the abutment on the right, the load traveled forward, stopped, and was shifted back past the center to the right to clear a second abutment on the left side of the track, also giving about 1/2 inch clearance. 76 feet further down the track, after successfully clearing the 2 obstacles, the load was shifted back to center and locked back into place. The rail crew physically inspected the load and rail car to verify the load remained secure during the hydraulic shifts and all safety procedures performed. All safety procedures were followed at each marked and unmarked railroad crossing along the route, reducing speed to 5 miles an hour. Maximum speed mandated by the railroad for this transport was limited to 25 miles per hour, as stopping a load of this magnitude and weight would take a greater distance than normal. Speed was also reduced to 5 miles per hour when passing other rail loads on adjacent tracks, requiring careful watch for close clearances, as track centers are not always constructed to accommodate loads of this scale. As the load reached Wallensburg, Colorado, the train conductor advised the crew that there were 2 8-degree left-to-right S-curves through town. To maintain safety at all times, the movement of the other rail cars was stopped. Crews boarded the lead-end operator's platform of the BBC X1000, where the center of gravity scale could be monitored to make sure no issues would develop, which would require shifting to keep the center of gravity within safe limits. Through careful engineering, planning, and operation, the BBC X1000 arrived at the project site in Pueblo, Colorado 6 days ahead of schedule. Originally planned for 14 days, the nearly 1,000-mile journey was made safely in 8 days. This project marks the 35th anniversary of the BBC X1000 and its primary operator, Stig Broman. Assisting Stig was Carl Yeoman, who has been working with the BBC X1000 for years. After 35 years, the BBC X1000 is still a one-of-a-kind, state-of-the-art rail car. In the past few years, it's been updated with a new hydraulic system and the latest technology, including GPS location and bearing heat detection. It can transport super loads in a multitude of configurations, transporting cargoes to locations where other methods are just not cost-effective or feasible.
About your people-sized Tonka toys, this is a Schnabel. It's carrying a heavy load. Of what, to where, and why?
1 million pounds is not uncommon for a generator or turbine nowadays.
Oh, but getting them moved to where they need to go takes plenty of power and know-how. That tops tonight's Your Money, Your Business.
Here is News Channel 8 and Portland Business Journal reporter Joe Smith.
Good evening, Laurel and Tracy. If it's big, weighs a ton, and needs to be moved, Portland's Emmert International is the go-to company to get it done. The bigger, the better. But in order to get something from here to there, it takes skill, engineering, and a whole lot of imagination. They're known for moving things. Big things. Like houses.
We don't care what it is, as long as it's heavy or oversized.
That's how Portland's Emmert International became a mover, shaking up an industry of just a few.
Nobody does all of it, the road, the rail, and the ocean shipping.
But they do. Terry Emmert's dad, Terry Sr., started moving houses in the late 60s. Over time, other overweight and oversized things needed moving. The Spruce Goose landed in Oregon, traveling up the Columbia by barge and by highway.
You watching that sign?
This huge diesel engine was shipped to the Bahamas. In San Antonio, Texas, the Fairmont Hotel moved 3 floors of rooms through downtown streets.
Everything has to go as planned.
Including the company's latest project, transporting a generator made in Japan being shipped to Houston, Texas, that needs to be moved to Pueblo, Colorado. It will get there on a Schnabel car.
Schnabel is a German word for beak.
The 30-ton carrier is a partnership. Emmert International designed it. Eklund Industries in Tualatin made it.
This is the first one of these units that we've ever done before.
It took 2 years of planning and 6 weeks for these men of steel to cut and weld this shipping cradle.
We try to keep all of our fabrication and engineering locally, 1, so we can keep an eye on it, and 2, to keep the Oregon economy going.
The huge side arms will connect with the beaks like these. Gravity forces the arms to squeeze the generator and hold it in place for the ride on the 20-axle rail car. Total weight over 650 tons. As generators get bigger, it's a bigger challenge to move them. Engineering ingenuity takes over.
Size is a big issue. Tunnels aren't big enough.
In some cases, there's only 2 inches of clearance going through the tunnels. But after the planning and the execution and $3.5 million riding on the move, make no mistake.
There's no room for error.
That's for sure. The Schnabel leaves Portland today. It needs to meet the ship by May 20th for the long haul to Colorado. By the way, the History Channel is documenting the trip for a future program on what else? Moving big things.
Overall dimensions: length 398 feet, width 15 feet 4 inches, height 19 feet 9 inches. Gross weight as moved 1,975,700 pounds. Planning for the job: 24 months planning and permitting process, 1,150 hours of engineering, 1,975 hours of planning and coordination. Permits: approvals from BNSF, PTRA, CWRR. Physical elements encountered: gross weight of 1,975,700 pounds. Only being able to move during daylight hours. It was critical that every pre-designed hole, nut and bolt, and pin to be accurate. Load-bearing requirements of the wharf: 22 possible trouble spots, 2 impassable locations, bridge abutments with tight clearances on each side, 2 8-degree left-to-right S-curves, maintaining the center of gravity within tolerable limits, countless bridges, underpasses, and railroad crossings, close clearances of adjacent passing loads. Crews were present with the load 24 hours a day. Safety considerations: daily safety meetings. At crew change points, there was job briefing with the new crew and detailed clearance instructions. Limited clearances. Only being able to move during daylight hours. safety protection and equipment in use at all times, stopping and slowing distances, maintained all speed restrictions, marked and unmarked railroad crossings, close clearances of passing loads, maintaining the center of gravity within tolerances at all times. Dial indicators were installed at each end of the generator to ensure there was no added stress or pressure to the generator during the transport, and readings recorded at each stop. Emmert's safety policies in effect at all times. All equipment used to engineered guidelines. Impact and strain gauges were monitored to stay within safe tolerances. Emergency safety team followed during load movement. Execution: 600 man-hours on the job. Ingenuity and innovations. Modifications to existing equipment. Utilization of existing equipment to develop new transportation method. Working with the generator manufacturer to accommodate design and transportation needs. Custom-built and designed loading bed out of new, more efficient materials to further reduce overall weight. Efficient loading and unloading techniques. BBC X1000 is equipped with reduced pivot arrangement to reduce swing out on curves. New innovative loading bed designed to reduce overall height, which allowed travel underneath overhead restrictions. Using the generator to help support its own weight. Unique loading bed design allowed compression on the generator to stay within critical tolerances. Balancing calculations of loading bed and generator for compression tolerances. Designed a unique new combination of compressive shaft and load bed. Loss prevention. No accidents, no injuries, no incidents, no property damage, no loss of time, no structural damage, no cargo damage, no equipment damage. Project also consisted of 71,000 loaded freight miles and 2,864,000 pounds of additional accessory cargo transported from the ports of Long Beach, San Diego, and Houston, with final delivery to the Comanche site in Pueblo, Colorado. Schedule: ahead of schedule and within budget. Contract: lump sum firm fixed price. All operations were safely performed under the care, custody, and control of Emmert International.